Well, good evening. My name is Steve Runnels. I'm the warning coordination meteorologist with the National Weather Service, and joining me is Kyle Perez, also one of our meteorologists at the Springfield National Weather Service office. And we want to thank you for joining us for a look at the upcoming winter season. And without further ado, I'll turn it over to Kyle.
Thanks, Steve. As Steve mentioned, I am a meteorologist here at the National Weather Service. I've been here for about 3 years now. And really look forward to presenting you guys with some great information tonight, and hope you're able to pull at least a couple new things from this presentation. Just one more check, Steve. I'm good on audio. Does everything sound good?
Yes, sir.
All righty, we'll go ahead and get started then. So for those of you that are not familiar with using GoToWebinar interface, you will see a tab down on your interface that is labeled questions. That is where you'll be able to post your questions throughout the webinar. Steve will be keeping an eye on those through the webinar, and at the end of each section, I will take the time to answer any questions that he may pass my way. And all attendees will be muted through the webinar to prevent any kind of background noise throughout the course of that. So here are the 6 different webinar topics that we have laid out for tonight. The first one, we're going to take a look at the winter of 2021-22 outlook. Then we'll take a closer look at some of the National Weather Service winter products. Some more interesting dive into the winter science and forecasting. And then we'll kind of wrap it up towards the end with measuring the snow and ice, taking a look at the different ways to measure snow versus ice, and as well as sending those reports to us. And then we'll finally wrap up this evening's webinar with building a weather-ready nation, and encouraging everybody to help in building a weather-ready nation and become weather-ready nation ambassadors. So let's start off with a poll here. Steve will be sending that poll out here for you to answer. It should appear on your screens. How much snowfall did Springfield, Missouri observe last winter? So that'd be December of 2020 to February of 2021. You should see that poll now. Choices being A, 10 inches of snow, B, 14 inches of snow, C, 18 inches of snow, and D, 22 inches of snow. Let that go for another 15, 20 seconds here, and then go ahead and collect the answers for us.
Looks like the responders have just about stopped.
Okay, yep, go ahead and wrap that poll up. It looks like the majority of the responses, with 44%, was 18 inches. The second highest response at 33% was 10 inches, and 14 and 22 inches had 11% of the vote respectively. The correct answer would have been 14 inches of snow. We officially observed here in Springfield, Missouri. We do the measurements here at our office daily during the snowfall during the winter months, and we ended up with around 14 inches of snow, which as you will see coming up in the annual climatology of snowfall, where that falls respectively with below or above normal. So let's dive into the winter of 2021-2022. These 2 particular graphics here on the left depicts the temperature outlook for winter, and on the right hand side is the precipitation outlook. So these are put together each year by the Climate Prediction Center, one of our partners. And they, as you can see here, it outlines across portions of Missouri and south central Missouri, slightly leaning above average in temperatures for the winter of 2021-2022. And then taking a look on the right-hand side, you can see with precip, we're going to lie somewhere in that leaning above normal precip too. So how do we interpret this, and what exactly does that mean? Because, you know, we're still going to have our cold shots, and it's not going to be above normal necessarily through the whole winter, but more or less we're going to see those above normal temperatures maybe more often than normal. And the same thing to go with precipitation, leaning towards slightly above. So that kind of ties into where are we getting that forecast? Well, one of the big things that we look at is different types of climate patterns. And the big ones that we always look at are the El Nino versus La Nina. Looking at this here, a particular graph on the right-hand side, you can see highlighted in the yellow box there is the December, January, and February timeframe. The chances of La Nina are greater than 90% for this particular part of wintertime, with El Nino being less than 5% and neutral around 10%. So what does that exactly mean then? Because it seems like we got a pretty good bet for a La Nina winter. So what do La Nina winters typically look like? Here is a diagram that kind of depicts what you can expect with a typical La Nina winter pattern. As you can see here, kind of matching up with the Climate Prediction Center's thoughts, you can see that there's that area of wetter conditions across the Ohio Valley into the mid-Mississippi Valley, including our area. But the other thing I want you to take note of is this big arrow, blue arrow that jets across the entire part of the United States in the central part there. And that is going to be our variable polar jet stream. So as I mentioned earlier, we can see quite a variance with that polar jet, you know, moving further north and moving further south. And as that does happen, we will see our fair share of cold shots, in addition to our fair share of warmer shots as well, with the return of warmer air south of that polar jet stream. So when do we typically see our first measurable snowfall in the Ozarks region? Looking at this particular map here, this is the median date of first measurable snowfall. You can see that generally starting across portions of central Missouri and our northern part of our county warning area, you're generally talking about in that December 1st to 10th time frame, maybe falling closer towards the middle of December. And then as you go further south towards, you know, say Branson, West Plains area, the Missouri-Arkansas border, you start to fall later in the month of December, generally leaning towards mid to late month before you see your first measurable snowfall for those portions of the region. And as I mentioned earlier, we received 14 inches of snowfall this previous winter. And so this is taking a look at the average annual snowfall by 30-year normals. And what we've kind of taken note of is a trend downward over the past, this is looking as far back as 1961. So beginning on your far left there, you have the 1961 to 1990 30-year normal. Upwards of 19 inches is what our average was for snowfall. And if you take that all the way up to present, the 1991 to 2020 being our current 30-year normals, that is closer to the 14-inch mark. So kind of about right where we ended up actually last year. So about a 5-inch difference than what we've seen since the early 1960s and 70s and 80s. So to go along with that as well, there's also been a number of 6-inch or greater snowfall episodes declining sharply. So we're not seeing those very large snowfall amounts, snowstorms that we used to, but we are starting to see a slight increase in the number of light icing events over the past 10 to 15 years. And that is not actually depicted on this graphic here, but we did run over some other stats that did show that we are in fact seeing a rise in those. So I will stop there for a brief moment if Steve has any questions from the audience to pass on.
Kyle, we have no questions at this time, but to remind everybody, all you got to do is go to the GoToWebinar GUI. There's a pull down message or pull down spot for questions. Just type in your question and we'll give it on to Kyle to answer at the next break.
All right, thanks, Steve. I'll go ahead and dive into our next section here. Now we've kind of taken a look at what we're looking at for the 2021-22 outlook. So we still have to be prepared for, despite those above normal temperatures, we're still going to have our bouts with cold and the potential of, icing, our snowfall, shots of cold air as well. So let's dive into the different NWS winter products we have. So this particular graphic here on the left-hand side, you can see shaded in the purple will be our advisory that we will take a look at. Then you have the warning, which would be in the red or the pinkish magenta red. And then you have in the bluish color, the winter storm watch. So with respect to winter weather advisory, what are the main things we want you to know right off the bat? We want you to use caution, and there's going to be minor disruptions expected. Then once we start to gain more confidence that this could be maybe of a bigger deal than an advisory criteria, that's when we would introduce a winter storm watch. This means warning conditions are possible in the near future, and it's time to prepare. And then lastly, winter storm warning. That is when life-threatening conditions are likely, and it is time to take action. So I'll dive into more detail on some of these and how we exactly go about issuing those particular products. So beginning with a winter weather advisory, they're generally going to be issued for your 2 to 5 inch snowfall amounts. And now these are not necessarily set criteria that we are always looking for, because it can be for less than that, especially if impacts are expected. So if 1 to 2 inches of snow falling on a Saturday evening is a lot different than it falling on a Tuesday morning in the middle of rush hour. The impacts are going to vary from those different times, and other factors include holiday travel. Taking the same sort of example, 1 to 2 inches of snow falling during a random day in the middle of February is going to be a lot different than it falling as everybody's on the roads traveling during the Christmas into the New Year's time period. And then lastly, it's also issued for smaller amounts of sleet or freezing rain and drizzle. So this is why we really don't want you to let your guard down when a winter weather advisory is issued, because as many of you know across this area, it doesn't take much freezing drizzle or freezing rain to create problems on the road, especially when the roads are cold enough to sustain, producing a thin layer of ice on those roadways. Oops. That takes us to our next one, and a winter storm warning. This is when we're generally looking at 6+ inches of snowfall, and it can be issued actually for less snowfall. Definitely, if there's a combination, of sleet, freezing rain with, accumulating snowfall as well, and we believe that those impacts are going to reach the warning criteria, we will not hesitate to issue a winter storm warning. So these are going to be a little more less common than the winter weather advisories, as you'll see coming up on the next slide. But we definitely want everyone to be aware of what a winter storm warning is. So as I briefly mentioned there, these particular two graphics, first starting with the one on the left-hand side, this looks at how many annual winter weather advisories we issue for our area. The darker shader blue color is generally going to be around 8.5 on average warnings or advisories, and then kind of dropping off towards 7, 6 or so. So what you can really gather from this map is, on average in our area, we're going to be issuing somewhere along that 6 to 8 winter weather advisories through the course of the winter time. And then if you look on the right-hand side, this depicts the same thing as on the left, but this is for winter storm warnings. And you can see that there's a substantial drop-off. So while we're issuing closer to 6 to 8 winter weather advisories, we're probably closer to that 1, maybe 2 winter storm warnings issued per a given winter season, with the highest chances generally occurring across portions of central Missouri, where the higher frequency is occurring for the winter storm warnings being issued. So a new product that we also have, this product we have not issued yet here at the National Weather Service in Springfield. This product is the snow squall warning. So it's going to be issued for short-lived but very heavy bursts of snow along with strong winds that create blinding visibilities. These are your typical events that are going to be associated with potential highway pileups. We've seen numerous cases across portions of Iowa and even up into other central United States, where these particular snow squalls have created very dangerous driving conditions in a short period of time. So if one of these is issued, it is a big deal. Here's a particular video here. I'll go ahead and play. Looking back at one in St. Louis back in 2008, where you can see how quickly this just comes in, where it just goes from generally clear conditions, and then that snow squall comes through, and then visibilities just rapidly drop, and you see some ice, snow start to accumulate there on the webcam. Just kind of gives you an idea of how fast that can really happen with those snow squalls. Another product that we hope to not use too often, but we have definitely had our fair share of these particular warnings, is the ice storm warning. These are issued when 1/4 of an inch of ice accumulation are expected on round objects like power lines. And then we also talk about flat versus radial ice. So when we're concerned about that 1/4 of an inch in ice, we're concerned about the radial ice and how it essentially builds up on power lines and objects. But there's also a flat ice that develops, flat ice measurements. And we have found that impacts really increase significantly as that radial ice approaches a 1/2 inch or greater. Going back, for example, that one everybody's probably familiar with if you've lived in the Ozarks your whole life would be your 2007 ice storm, where much of the region was blanketed with 1 inch of ice or greater. And lastly, on the winter weather products would be your blizzard warning. These are going to be issued with winds greater than 35 miles per hour, with visibilities less than 1/4 of a mile. And the main difference between that and a snow squall would be that the blizzard warning has a duration of 3 hours or greater. And one thing we definitely don't want you to forget about, especially after the February that we just had here in 2021 towards the latter part of this winter, would be our winter wind chill products. Beginning with the wind chill advisory, this is going to be issued with wind chills of greater or less than or equal to -15 degrees. And then once we start getting into the wind chill warning criteria, which we did hit this past February, is going to be wind chills of less than -25 degrees. So this is extremely dangerous conditions, and it would not take long for anybody that is outside to, with exposed skin, to potentially be exposed to hypothermia and all the dangers that go along with cold. So that kind of brings us to poll question number 2 here that Steve will be sending out. And I was going to send out here, when is the last time NWS Springfield issued a blizzard warning for any part of the coverage area. So for all you folks that keep track of your National Weather Service products that we issue and keep an eye on us, when was the last time we issued a blizzard warning for any part of the coverage area? The first selection would be A, January 31st, February 1st, 2011. B, January 12th and 14th, 2007. C, January 5th of 2014. Or D, February 14th through 15th of 2021.
Okay, Kyle, we're starting to get some responses in. About half the audience has voted.
Okay. Looks like, yeah, so it's looking like majority, we'll go ahead and collect that poll there. So it looks like the majority of the vote that came in selected the correct answer, and that would be the January 31st through February 1st of 2011. That is when our last blizzard warning was actually issued for our coverage area. Some kind of trick answers on there with some of those other ones. January, the answer B would be your major ice storm warning. C being a pretty significant snowfall event, but was not a blizzard warning. And D being our most recent snowfall and cold bout that we had here in 2021. Any questions for that section, Steve, that have came in on NWS winter products?
We haven't had any questions, but we have had some people talk about some of their past memorable events. John McBride, for example, January the 5th, 2014. So we got some people out there who have some fond memories of winter weather in the Ozarks.
Absolutely. It's been a while since we've got a good one. So for any snow lovers, we'll see what we can put in the forecast for you this winter time. So I'll go ahead and take a dive here into the next section here of winter science and forecasting. So the question always comes up of what precip type are we going to see with this system? It's something that we continue to do research on in the National Weather Service and the meteorological community because there still remains some unknowns exactly of how to pin down those forecasts because all it takes is sometimes a half a degree warmer aloft, half a degree warmer at the surface, and all of a sudden we're talking about different precip types. So looking at this particular graphic here, this kind of gives you a general idea of what we're looking at when we're looking at winter precipitation. Beginning with the left-hand side there of this graphic, you're going to have your snow. It's you're going to have at or below of 32 degrees Fahrenheit through the entire vertical column of air, all the way from aloft all the way down to the surface. So those snowflakes never melt. But then we start getting into our mixed precip types. So how do we get those? Well, with the sleet, here you can see on the second one, it's going to begin as ice crystals or snowflakes, and then you're going to fall below that orange layer there, which would represent above 32 degrees. So those ice crystals and snowflakes will then melt, but then they will then fall back into a layer of below freezing temperatures, and those droplets will freeze and form ice or ice pellets before reaching the surface, and that is what is known as sleet. Now, the main difference between the sleet and freezing rain, starting there with the third one there, is you're going to have the snowflakes get into that warm layer, but it's going to be a much more deep layer of warm air. So essentially what is going to happen is those are going to stay, the snowflakes are going to melt completely through that layer. And the only thing that is going to be frozen then is going to be the surface at this point. And that is what makes freezing rain so dangerous, is that it's going to appear as it's maybe just raining outside, but with that below freezing surface, any of those rain droplets are going to then freeze on contact with the surface. And then lastly, your rain, where you do not have that frozen surface. You'll essentially just melt those ice crystals higher up aloft in the column, and they will never refreeze. However, there can be a particular concern that I will be coming up here in the next few slides with rain falling on a potential surface that could freeze within the next few hours afterwards. So there is where we kind of wrap into the flash freeze. So we could have, snow falling on pavement that is above freezing and it results in wet pavement. Or you could also have scenarios where, you're getting very cold rain falling on a wet pavement and the temperatures are still above freezing and so are the pavement. However, they might be very close to freezing and it might just take some stronger incoming cold air. So as you can see on the right-hand side, I had to depict with the much stronger cold air pushing in behind that frontal passage. And what will happen then is essentially with those wet roads, as soon as those pavement temperatures fall below freezing, it can quickly develop icy pavement and what we reference as flash freeze potential for the roadways. And that also kind of is a similar process that is going to take place with your black ice that occurs, where you have wet pavement either melted by salt or the sun, and then you get the cold overnights that will quickly freeze that onto the pavement. Also taking a look at some of the science of wind chill. When we're talking about wind chill, what exactly is wind chill taking a look at? Well, essentially it is looking at how air is moving the heat away from your body. So the image here depicts on the left, no wind, where you have the body radiating heat and all your layers are able to create a warmth between your skin and the cold surroundings. But then when you get those windy conditions, and it doesn't take much, once you start talking 10, 15, and you get pushing 20 miles per hour wind, it will quickly move heat away from your body and thus reducing your body temperature if not properly dressed for the wintertime. So what exactly do we use for measuring the wind chills? So this is a wind chill chart here that we use at the National Weather Service. The top bar will show your temperatures here. So this will be your actual ambient temperature, and on the y-axis here, or your left-hand bar going down here, this is the wind speeds going up from 5 all the way up to 60 mile/hour. So it does not take much, as I mentioned. So if you have a night with lows generally around 20, 25 degrees, and you start getting a 20, 25 mile/hour gust, you're already going to be in that single digit to teens with as far as wind chills go. And as I mentioned earlier, it did not take much last year for us to start falling into those very low values into the wind chill warning criteria. And those colors shaded on here actually show the frostbite times. So once you start looking closer at, temperatures or even winds accessing 30, 35, and you got those temperatures in the lower teens, you're quickly going to start reducing the amount of time for frostbite to kick in closer to 10 minutes and even 5 minutes in extreme conditions. And then finally, kind of with a forecast part here of this section that I wanted to dive into just a little bit, was what exactly are we showing you with our forecast? I'm not going to get into the details of the probabilistic data and such, but this is on our page actually. This web link will be available for everyone. Steve could probably post it actually in the chat if for anybody that's interested. So this is our winter page that actually shows you our expected snowfall amounts, where you can look at a point in different ranges. and that is pictured there on the left-hand side. But then you also see these two other little graphics on the right-hand side. So these are actually derived from all of our data and probabilistic data. So the top one would be your 1 in 10 chance of a higher end snowfall. So this is going to be much more rare, but it definitely could be possible in some cases. And then your lower end amount is going to be your 9 in 10 chance. So that is your 90. You have a 90% chance of that amount of snowfall at least occurring. So that's your low end amount versus high end amount. That will wrap that section up. Steve, any questions to pass on?
No, we do not. We do continue to see some people give us their favorite aspect, or I should say least favorite aspect of wintry weather in comments. But I thank all. Again, if you're new to GoToWebinar, just click on the red arrow, which will pull up a option box marked questions. Pull that down arrow and you can give us your comments or your questions there. Thanks, Kyle.
All right, thanks, Steve. Moving on to measuring snow and ice. This has really become an important part of our agency and how we continue to grow. And everybody's reports are important to us. We encourage everybody to participate in measuring snow and ice, and those reports could go a long way for us, and we appreciate any kind of reports that are able to send in. So let's begin with measuring ice. I mentioned earlier in the presentation that there is two different measurements of ice that we look at. There's the flat ice measurement and there's the radial ice measurement. The radial ice measurement is going to be the one that we make our warning decisions based off of. So we're generally looking for that 1/4 inch or greater for potential ice storm warning criteria. But we also use flat ice generally as a measurement too. So flat ice is going to be found first by finding a flat surface that is undisturbed, generally from the surrounding environment. You don't want it close to your house, any kind of overhangs, trees, things of that sort. And you essentially just measure the ice accumulation from the bottom of that surface to get your measurement. All measurements for ice are rounded to the nearest 1/10 of an inch. And then for the radial ice measurement, you will actually, as you can see in that image there on the right-hand side, you're going to measure those two sides of the radial of a twig or a branch, and you measure those thicknesses of both those ice on each side, and then you take the average of the two measurements, just divide it by 2 to get your total radial ice accumulation. Another way that people have also taken on measuring radial ice measurements would be measuring that entire area there from the ice, from the top to the bottom there, and then also measuring the twig size in the middle and subtracting that out before dividing. So there's many different ways to go about it, but essentially we're looking for those two measurements of the ice and then dividing that by 2 to get your final radial ice. And any measurements that are going to be below 1/10 of an inch are going to be reported as a trace. Now on to measuring snow. This is the fun one because, as you know, it could be tough to measure snow, especially if we got 25, 30-mile-an-hour winds creating some fun drifts out there. We definitely don't want people to send us their drift measurements because those can get pretty extreme sometimes, 2 to 3 feet when you actually only have 4 to 5 inches of snow on the ground. So first off is gathering the supplies that you need for measuring snow. We encourage anybody that is going to take official measurements and send them to us to find a flat board, like just a whiteboard, any kind of like flat surface like that. And that's what we're going to be using for our actual measurement. You also will need maybe a post, like a kind of marker or flag for where you're going to put that board. and then also finally your ruler for measuring. So when you're planning for putting this particular snowboard out, we want you to find an open area away from tall objects, but you want it to be sheltered from the wind. So don't put it out in the middle of your pasture or places of that sort that may be obstructed by the wind, but also don't put it right next to the house where drifts are going to build and such. So when you set this up, make sure you put the board out and mark it with a flag. If you start to get several inches of snow, that board could quickly disappear underneath the snow pile there. And then finally, we're gonna have our snowfall. So what are you gonna do when you measure the snowfall? So we want you to go out there and record your total to the nearest 1/10 of an inch. And we want you to measure at least once daily at the same time. And after measuring the snow, place the board on top of the snow after clearing off the current snow. So you're going to keep track of those measurements and how it progresses through time. And finally, some big important tip that we want to leave everybody with is to make sure you measure as soon as the snow stops to avoid any lower totals due to melting, settling, or drifting that can kind of make for obscure snowfall measurement amounts. So one other big takeaway that we definitely want to watch for is avoiding measuring in any kind of grasses. You know, this board is definitely going to be the best way to go when taking accurate measurement because once you start talking about measuring with the grass being involved, it can make for much more difficult accurate measurements. That kind of wraps that section up. Steve, any kind of questions with regards to measuring ice and snow?
Kyle, we did. Jim Benucci asks, can you report thunder snow on mPING? And the answer to that, Jim, is no, you cannot. There's a lot of different information that you can share back with the National Weather Service, whether it be wintry weather or severe weather, but thunder snow, unfortunately, at this time is not one of those weather types. Thanks, Jim.
Yes, thanks for that. You know, and that helps lead into this next section topic as well, and that's sending reports. I'm actually going to take a closer look on sending mPING reports. That's great to know that we already got some folks out there that are familiar with that. There's lots of different ways to send in reports. Starting with that left-hand side, you know, you can tag us on social media or just give us a call at the office with your particular reports. You know, how much ice or snow are you seeing in your particular area? And then we also have available there our email. If you do email us pictures of snowfall, we encourage you to include a ruler in the picture with your measurement and let us know what you're measuring on. As I mentioned, hopefully a snowboard if possible, but if not, kind of let us know where you're taking that particular measurement and show us with the ruler in your picture. That'd be great. Another one is the INWS, this particular link here that will be available to you as well. And this particular web interface will allow you to submit reports that will be sent directly to us as well. And then lastly, as was just mentioned, was the mPING app. This is another great way to send in reports. The great thing about the mPING app is that you know, those appear pretty much almost real time. There's not too much of a time lag there, and we get those fairly quickly with that exact location of where you submitted that particular report, whether it be rain, snow, or ice or such. So kind of walking through on how to send different mPING reports. So first, if anybody's not familiar with the mPING particular app that you can get on your phone, that's all you'll want to search in your particular app store is just look up mPING, and you should see that appear, the mPING project appear as a app for downloading. It's a free app. And essentially what this is a project that is being conducted that is live, and you know, we've been doing it here I think over the past 2 years at least, with NOAA and Oklahoma University, where we're actually have put this together with this interface where you can send reports. The first thing you would want to do there in the interface of the mPING is select your report type. That will lead you to this particular window where you can look at all the different report types, ranging from rain, snow, hail. Then you get kind of severe, reduced visibility. Those are great ones for us to know. And then after that particular step, you will select rain, snow as you see fit. And then lastly, you will submit that report. And you will get a notification that your report was successfully submitted. And then that will send it to us where we will see it on a particular map and can help us greatly in making further possible forecast and warning decisions if need be. But at the very least, it's going to help us with a verification process, getting some ground truth of, what's occurring out there and how can we fine tune our forecasts in the near term. Another great way to send in reports is joining the CocoRoss program. It's not strictly, the CocoRoss program is also used for measuring rainfall totals, where you can actually buy gauges and an official rain gauge and take measurements and log them daily. And those are all available to pretty much anybody to see, including us. And those are very helpful reports when we're able to gather a wide variety of CocoRoss reports across the area, especially when we start getting into those areas where we don't have any observing equipment. That's definitely a great help. We have different people, they're co-op observers, so they essentially are observers that we have that have some of our official equipment and make official measurements and can send measurements to us. But the CocoRoss program is essentially a volunteer program that's available for everybody. So I encourage anybody that's not involved with that to take a look at that. Any kind of questions there, Steve, on sending reports and great ways to send them in?
We have had a question come in from John McBride, and the question is, how far should the snowboard be placed from the tree? And John, the general answer, whether it be for taking snowfall measurements or rainfall measurements, is that your gauge should be placed 2 times away from the height of a house. So when it comes to something like a building, moving your snowboard or your rain gauge, again, 2 times the distance away from the height of your house is the general thought. When it comes to trees, obviously there's a couple of elements there that trees are going to also interfere with your snowfall readings. The first is they're going to block a lot of that snowfall from reaching the ground. The second is that those trees will block the infrared energy being released from the earth and might cause significant changes in that snowfall amount underneath that tree. So I think that the general rule of 2 times away from the tallest object will likely also give you a best idea of where to put that snowboard as well. Thanks, John.
Thanks, Steve. So building here into the last section here, this is just a brief overview of building a weather-ready nation. And the building a weather-ready nation message has really come to the realm here over the past, I think we're probably approaching the past 5 to 10 years now. And it's definitely been a big core part of the Weather Service. So what exactly does building weather-ready nation look like and mean? I think the best way to look at it is having that community resilience and preparedness. Everybody is, essentially beating to the same drum. Everybody is weather ready and they are weather aware, and that's what we're going to continue to strive for here over the next several years as well, with building that weather ready nation. And there's many different ways, that we continue to push our message of preparedness and safety, everything from our graphics to our webpage. They all have great sources, but there's also, great opportunity for not just looking at what we have to offer, but there's also other entities within the Weather Service that continue to push the same message with aviation, with marine. Those are all important. And, I kind of just want to encourage everybody to make sure that, you know the forecast before you go. And, when we're kind of building into the winter months here, have a good idea of the forecast before you go. Can kind of be easier said than done. Winter forecast can change very rapidly within a short period of time. So just have that awareness of how you can be better prepared, whether that's your home being better prepared this winter time, making sure that you have an emergency kit in your car. That's always important as well. If you were to get stranded out in the highway, if the highway were to get shut down, those are all great examples of why you could really benefit from having those extra blankets and anything that you may need if you were to be stuck in your car or your home for that matter, in the event of a major winter storm or ice storm that may make driving impassable for a couple days. So those are all great things to know going into the winter months. So, that kind of builds in, we continue to try and serve everybody better as, how can we better serve you? So that kind of leads us to the third poll here. And there's no right answer to this one by any means. Steve will go ahead and launch that. You also have the opportunity to select several answers. Whichever these, we're looking for what future or futures are most important to you in on a winter weather graphic. So we have really tried to hone in on what the public wants to hear from us when we're forecasting winter weather. So some different options here include timing, locations, our confidence level, what are the amounts, and I also have a category there for other. If you want to, feel free to put that in the questions area of some other things that you feel are important on a winter weather graphic or sending it out.
Okay, Kyle, the votes are slowly coming in. We're about at 44% of the audience. So got a few more people out there to vote. Maybe a few more seconds. Yeah, just had a few more votes come in. Let me go ahead and close it and people can see the results.
Thanks, Steve. So yeah, it looks like 60% of the vote definitely has a huge interest in snowfall mountain timing. So that's great information for us to take back with us to our graphics building here. And also it looks like there's a high interest in locations. One thing to say with locations is it can change, and we encourage everybody to read up as much as they can on the potential changes, because as you know, snowfall gradients can be tough to forecast sometimes with all it takes is a few miles north or east, and all of a sudden one area gets a lot more and one area kind of gets left in the dust with a little bit. So that's great information for how we can better serve you this winter. And that kind of wraps up everything I have here to present today, with the last part here kind of encouraging everybody to become Weather Ready Nation ambassadors. Our ambassador program is an opportunity, there's no kind of fees or anything like that. Our ambassador program is essentially going to be where we collaborate with you at the National Weather Service. You have the opportunity to share your success stories you know, whether that's weather safety, you know, a particular business, how they are better prepared for weather. Do they have a safety action plan in place? All those particular things of helping build that weather ready nation and become more weather ready and resilient to any kind of weather emergencies. And lastly, I left us there with our contact information down the left-hand side in different ways. You can look at our information, call us, email us, or even find us on social media as well. So we'll kind of wrap up there. If we got some questions, Steve would be happy to field any kind of questions that we have.
I just posted one last request for questions, so we'll see if anything comes in. But from my end, Kyle, I wanted to thank you. Great job. I really like the variety of information that you shared, and you know, it's unfortunate, but most people start thinking about winter weather after the first winter storm arrives. So not only do I want to thank you for presenting, but obviously everybody that took place in the webinar took some time out of their schedule to listen and learn. I wanted to thank you all as well. I see several thank yous out there. If you could maybe thank us by sharing this information with somebody else. Kyle mentioned social media. That is a great way for friends to help friends get ready for this upcoming winter season.
Thanks, Steve. Yeah, I guess I'll echo your thoughts as well. And you know, I did put together a Weather Service Springfield reference sheet for this wintertime with a variety of different resource information from different forecasts information, different things with vulnerable populations and how they can better receive the weather. So that's something we can actually follow up with as well in an email with all who attended.
Okay, so with that said, let's hope that, let's hope that whatever your wishes are for this winter season, that you get what you ask for. With that said, everybody have a great evening.